Hello everybody, this is going to be the video for exam 2 version 2, so for Panetta's class. I am recording the entire exam review just for ease on my part. However, I'll try to put a timestamp in there for when we stop in session, so then that way you guys can go through and just watch from where we end and get all the answers and make sure that you understand as much as possible. So let's go ahead and get started. Let's start with number one. Number one is find the derivative of the given function. Already we know this is product rule. Okay. And also I know that I'm going to rewrite this as z to the 1/2. And I'm also going to rewrite this mess as 8z to the 2/3. Just to make life easier, because I know that's power rule. Life will be a lot nicer if I just do that off the rip. So let's go ahead and get started. Also, if you hear that, that's my kitten, and she's a hot mess. Okay, all I did was set up my product rule, so derivative of f of g times derivative of f of x times g of x plus f of x times the derivative of g of x. And I'm just going to go through and derive. I know you guys already know how to do this, so I'm going to make it really quick because I don't want to waste too much of your time. 1/2 times, and then that's going to be 16/3 z to the -1/3. Okay, now I could leave it like this. I considered it. However, you can distribute and it might make life a little bit easier. So if I go ahead and distribute both, that is going to be -3/2 z to the -1/2 minus 4 z to the 1/6 plus 32/3 z to the -1/3 minus 16/3 z to the 1/6. Okay, so again, remember whenever you multiply something like this with 3 or this times this, you're adding exponents. So that's how I got those answers. Now I can do a little bit more shuffling around. I can add these two together. I can add these, or never mind, I can't add these two together, but I can add these two together to make my life a little bit nicer because they have the same exponent. So my final answer is going to end up being 32/3 z to the 1/3 minus 28/3 z to the 1/6 minus 3 over 2z to the 1/2. And that is the end of that. Anytime you have a negative exponent, it's going to go to the denominator. Hence why these are down here. And then anytime you have a positive exponent, it's going to be in the numerator. So hence for that being right there. So that's number 1. Again, I am going to post a answer key, but this is just so you guys can go through and watch and see if you're missing anything. I know the handwriting's not phenomenal, and I do apologize for that. I will do my absolute best to make this legible. Okay. Find the equation of the tangent line to this at x equals 1. So, equation of a tangent line, you have steps. Remember? So, step 1 is going to be find your first derivative. So, find x. Step 2 is going to be find your y value. And to do that, you plug x into the original function. So you'll just plug 1 into this original function. You won't do anything crazy. It's just you have a coordinate point like this. So there's going to be a number there. And you need that for the rest of your thing. Step 3, you're going to find your slope. And that is found by plugging x into your derivative. So once you find your y and your slope, then you'll plug into slope-intercept form. And turn it into y equals mx plus b form. So let's get cracking because this is going to take a second. Okay, so I am going to start with finding my derivative. This is a quotient rule. So you already know the drill. So low d high minus high d low all over low squared. Okay, so I'm just going to go through and do my derivatives. These are pretty simple derivatives already, so I'm not going to fuss too much. So x plus 2x squared times negative x cubed is going to be negative 3x squared minus 4 minus x cubed times 1 plus 4x. I do apologize for this handwriting. I do not know how to make this any better. All over x plus 2x squared squared. So honestly, at this point, I am simply not going to do anything else. I am not going to make this any nicer. I am just going to plug and chug because simplifying, I'm going to get too lost in the sauce, and I just don't want that. So for this, I'm going to do finding this, not slope, finding the slope in red. So that means I'm plugging 1 as the x value given to me into this whole thing. So it'll be 1 plus 2 times 1 squared times negative 3 times 1 squared minus 4 minus 1 cubed times 1 plus 4. And I know 1 plus 4 is 1, so I'm not going to keep writing all that crap. Excuse me, stuff. Oops. 1 plus 2 times 1 squared. Again, plug this into your calculator for you. For me, I'm not going to do all that for you guys. I'm not going to bore you with that. The slope is going to end up being negative 2.67. Okay. And it's actually like a really long decimal, but I'm going to spare you again. So there's that. I'm also going to do the y value in purple. So 4 minus 1 cubed all over 1 plus 2, 1 squared. And that is going to give me 3 over 3, which is 1. So this value up here is going to be 1. And now for the final piece of this puzzle, we're going to put it into point slope. That should be point slope. And turn it into y equals mx plus b. So y minus y1 equals mx minus x1. Y minus 1 equals 2.67 negative x minus 1. Do a little bit of distributing. Y minus 1 equals negative 2.67x plus 2.67. Oh no, you can't see it. Plus 1 on both sides to finish this off. So y equals negative 2.67x plus 3.67, and that is the equation of the line that you're looking for. Hopefully we'll get through this one in session, but just in case you need to look back at it, follow these 4 steps. It's important you know this equation and this equation. And probably y equals mx plus b, but I assume you guys already know that. So you guys are smart. Okay. Let's keep cracking. Okay. Find the derivative of the given function. This is going to be quotient rule. But if you look at this top function, hopefully you can see this yellow. This top function, this is one function and this is another. So that's also product rule. Now, to be fair, I would set up my quotient first. So do low d high minus high d low all over low squared, and then start working through product rule. That's probably your best way to do it because then it's all organized. So let's start there. I would also like to say, I don't think it's going to be this crazy, but I don't ever want you guys to think that you guys can't do problems like these. So let's start. Low d high minus, I gotta sneeze. Sorry. D cosine t. One all over low squared. Okay. I'm going to do product rule in purple, as I think it's easy to see. But first, let's start rewriting a couple things. So t squared plus 1. Okay, now product rule. I'm gonna put it in square brackets, just so then that way I can see it. It's easier for me to notice. So dt of t times cosine t plus t dt that should be cosine t. I just can't write. Okay, that's product rule inside of t squared plus 1 all over Okay, so let's get started. I'm going to bring down t squared plus 1, and now I am working within product rule. So again, square bracket, the derivative of t is just going to be 1. So 1 times cosine t plus, and then t times the derivative of cosine t. Now the derivative of cosine, as you know, should be negative sign, and it is. So there's that. Minus t cosine t, and then times 2t all over e squared plus 1. Okay, so now that we're sitting here with that, you could just leave it like this. I might clean this up a little bit, make it a little bit nicer to look at, and say t squared plus 1 times negative t sine t plus cosine t minus two t squared cosine t all over 1 t squared plus 1 squared. And then the answer the textbook gave me was a lot more derived than that. Not derived, a lot more factored out than that. Honestly, I think you could leave it as is and it would be fine, just because it's a little bit complicated already, and you've already shown that you understand how product rule and quotient rule work together. And I'll show you that in class if we have time. Okay, let's go to this next one. Okay, I also would like to point out I don't have a ton of e to the x and ln x derivatives on here. I suggest double checking them and going over them, just so you guys have a good basis. Natural logs and exponentials will be on the exam, maybe a little bit more than I've shown here, but I at least want you to get your feet wet and be aware that they're on there. Okay, so remember that e to the x, the derivative of e to the x is always just going to be, oh my goodness, is always just going to be e to the x. That's beautiful. Love dealing with that, because otherwise, awful. And remember, ln x is always 1 over x. If there is something more than this, it'll be chain rule. So, for example, if it's d to the x, ln x squared plus 1. It's going to be a little bit more complicated. It's going to be 1 over x squared plus 1 times x squared plus 1 times the derivative of the inside, which would be 2x. And that will be the derivative. But again, that's for you guys to go over and study. Don't get too caught up on it. I just want you guys to be aware that they will most likely be on this exam and that you should be prepared. Okay? So, let's go ahead and get started. I'm going to get rid of this really quick. I also would like to point out that there is not only just normal derivatives in here, we also have a product rule in here as well. And if you guys didn't catch it, where's my mouse? There it is. It's this right here. That's a product rule. Okay? This is one function, this is another. Okay? Just be wary that there can be more than one rule going on at the same time. I know you guys already know this. This is just to make sure that you are fully aware and you're looking and you're watching. So, let's go ahead and get started. Forgot the 3. Alright, well, actually, never mind. I'm going to pull the 3 out. Not for anything other than just for giggles and such. Okay, so 3 times d e to the x is going to be 3 e to the x, which is going to be 3 e to the x. Nothing changed, right? Perfect. Stellar. This one, however, is going to become... Why did I do that? There it is. Okay, cool. Like that. That's your product rule. We're just going to go ahead and go through it. So, bring down that 3. It's going to be 30x squared ln x plus 10x cubed times 1 over x. If I want to make this a little bit nicer to look at, 3 e to the x plus 30x squared ln x plus 10x cubed over x. And then, of course, you can, get rid of this, oh my goodness, this x and this x, and make that 3 e to the x plus 30x squared ln x plus 10x squared. Just doing a little bit of extra to get rid of that and make it a little bit nicer to look at. This would be fine. This shows that you understand how it works. I don't think it'll be a big deal, but if you are happier with this answer is also valid. So there's that. Okay, let's go ahead and get on to the next one. Okay, this is a, say it with me now, a chain rule. So you have the outside function, and then you have the inside function. Recall that the inside function, you have that little table. So CSCX negative CSCX cotangent x, Lord. So CSCX is you're going to cover this one right here. You're going to ignore it, pretend it's not even there. And the derivative of CSCX is going to be negative CSCX cotangent x. This is an FYI and a reminder. Now, because you have this piece in here, this piece is always going to go in where that x is. So you have negative CSCX, nope, not x. Oh my goodness. We're doing this in one take though, I'll be so honest. D over dw. So the derivative of the outside is going to be negative CSC. Keep that 7w because we're not worried about it yet. Times cotangent 7w. Again, keep that 7w in there because we're not on the inside yet. Times the derivative of the inside, which is just going to be 7. So your final answer is going to end up being negative 7 CSC 7w times cotangent 7w. And that's the end of that one. I can almost guarantee that a question like this will be on the exam just because she loves a chain rule and you guys need to know your trig functions. I would also like to add, which I do not have on here, please go over your inverse trig functions. Those you absolutely need to know. You don't need to know how to solve anything like this. It will simply be what's the derivative of sine or cosine or, cotangent. However, so be very, very cognizant of those. I would, make some flashcards, study them, get to know them really, really well. Unfortunately, I don't have a good way for you to remember those, but I would take the time to live them, learn them, love them. Because I'm almost can guarantee at least one of them will be on the exam. Okay. So this is another, say it with me now, chain rule. Okay. Again, this is going to be relatively painless, hopefully. So how this works is nope. 1 minus cosine x. Okay. So this is your inside. This is your outside, essentially. So the derivative of e to the x is going to be e1 minus cosine x. It's not going to change. Whatever this up here is for the derivative of the outside is just going to be this repeated, okay, times the derivative of this, okay? So 1 minus cosine x, it's going to be negative. So actually, sorry, I'm getting ahead of myself. So the derivative of cosine is negative sine. However, you have a negative sine x, so therefore the derivative of the inside is going to be sine x in this scenario. So here you have it. So e1 minus cosine x sine x. This writing is horrific. I'm so sorry. This right here is this. For some reason, my pen is just not liking that it's so small. This is going to work for any function that is e to the power of something. Okay? So, how it's going to work, it's going to be e to the power of something, the exact same thing down, times the derivative of whatever's in here. Okay? That's how it's going to work every single time. No matter how crazy this exponent gets, that's how the power of e works. Even, and to go even farther, exponential and natural log derivatives, go review homework, go review quizzes, go look at maybe a quick YouTube video, and just practice, because I am almost for certain a few of these are going to be on the exam, okay? And again, if I have time to tell you in session, I absolutely will. But if you didn't hear it there, listen to me now. It will absolutely be on the test. So absolutely get comfortable with them. Okay, let's move on. As I said, here we go once again. So this right here is a natural log. No, excuse me. It's not a natural log. It's an exponential function. I know words and things. This rule is going to be d dx a to the x, and that's going to mean it's going to be a to the x ln a. Okay? So this rule, again, live it, love it, learn it, get really, really good at it, because I know you guys know e to the x, I know you guys know ln x, those are simple. The ones you guys need to be careful on are these. And I do think we did have a worksheet that had all 4 of them on there, and I would definitely go back and review those as well. But anyway, okay, let's work on this derivative. Okay, 2e to the x, I already know it's going to be 2e to the x minus, and then I know this one based off this rule. Should not be anything crazy. It's going to be 8x ln 8. And then you're done. This is easy, painless, as long as you know your rules, okay? And I want this exam to be as easy and painless as possible, because it absolutely can be if you guys are good on rules like this. Okay, again, here's another one. This is going to be your logarithmic your log derivative. And I put a ton of these on here simply because I wanted to go over them, and I was worried that you guys wouldn't have enough time, but I know for certain she said to put these on here. So the rule is log bx is equal to 1 over x ln b. Okay, so already I can pull these coefficients out. If this is too much for you and you don't like that these are sitting here and it messes with this rule, pull them out, okay? So 9d over dx log base 4 to the x plus 12d over dx log base 11 times x. So again, I'm just plugging the formula in right here. This is nothing crazy. So 9 times, it'll be 1 over x ln 4 plus 12, 1 over x ln 11, which probably should put parentheses around these just for nicety. And then, you know, make that all nice and together. And this is it. That is the end of that. Again, please, 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 if I have not told you once, I told you already 3 or 4 times, go review your natural logs, go review your exponents, go be very, very comfortable with them. Just like your inverse trig functions, go be super comfortable with them, because they will come back and they will bite you in the butt if you are not paying attention. And that's a silly mistake that we don't want to make. We want to make hundreds in this class. Okay, so this is a really, really nice one. This is chain rule, and this one is really, really easy to spot. So the whole outside is going to be something to the 4th. The whole inside is this piece. So the outside derivative is going to be 4x squared plus 7x to the 3rd times, and then the derivative of the inside is going to be 12x plus 7. Now, honestly, I'd leave this go. I wouldn't go any farther than this. This is really, really easy for you to see, and you demonstrate that you understand how it works. To go off and, make this any more complicated, excuse me, you could, distribute the 4 into this piece right here. But honestly, so if you wanted it to be x squared plus 7x to the 3rd times 48x plus 28, you totally could. That's also equivalent. It's fine. But again, it's just if you really think she's going to count it against you. This should be one of your easy points. I know you guys know chain rule in this scenario, so this shouldn't be too bad. I'm for certain at least 1 or 2 chain rules are going to be on there. Those are one of the best rules to use because it really, really tests students' knowledge and understanding of derivatives and their rules. And so it's one of the favorites. So I would be very comfortable with chain rule. If you're not, go back and do the extra practice I sent out and watch the extra practice video, okay? So let's get moving. Okie dokie. Okay, this is implicit differentiation, our favorite. So let's get something really, really straight, really, really fast. Anytime you have x's and y's together in the exact same area like this, this is an instance of product rule. Okay? I usually do it off to the side just so that way I can keep my life straight. And I also usually pull the 4 out. I pull out my coefficients just because I don't want to deal with them. So here's how I do that. Okay, pulled 4 out. It's just going to kind of follow me all the way down. But now x squared is 1, y to the 7th is the other. And then that way I just have to do not chain rule. I just have to do power rule, and it's really, really simple. So let's go ahead and get that started. 4. Probably should make this a square bracket. Anyway, okay. 4. So d dx x squared. That's regular differentiation, so it's just going to be 2x times y to the 7th. Cool, that piece is done. Plus x squared, and then y to the 7th is going to be implicit differentiation because I'm deriving with respect to x, and this is an x. So that's still going to be 7y to the 6th times dy dx. Okay? Now, I'm going to write this a little bit nicer, and then I'll redistribute that 4 back into there. 2xy to the 7th plus 7x squared y 6 dy dx. Okay? So, now that I have all that, all the work is technically done, I'm just going to redistribute my 4 back in. So I will have 8xy7 plus 28x squared y to the 6th dy dx. Okay, so I finished that piece. That piece is done. I'm just going to leave it go for right now. I'm going to go back to all my other ones that are just a little bit easier. So okay, so d over dx to the times negative 2x d over dx, that's just going to be negative 2 equals x to the 5th is going to be 5x to the 4th, that's just power rule, plus, and again, this is implicit differentiation. It's an instance of y instead of x, so it's going to be 12y squared dy dx. Okay, so I'm going to write this all nice and beautiful. The 7th plus 28x squared y to the 6th dy dx equal, no, nope, it's not equals yet. Minus 2 equals 5x to the 4 plus 12y squared dy dx. Okay, so now I need to get dy's and dx's on one side and everything else on the other side. To do this, I am going to move 5 to the 4x over to this side, and I'm going to take this 28x squared y to the 6th dy dx, and I'm going to move it over the other side. And that's just because I want to do the least amount of moving and shaking as possible. So I'm doing this just in one quick swoop. So, oh no. Make that little line. Do a little bit of erasing. Okay, so on one side of my equation, I have 8xy to the 7th minus 5x to the 4th minus 2 equals 12y squared dy dx minus 28x squared y to the 6th dy dx. Okay. That should be plus. Now I have plus. Okay, cool. Okay. I'm going to pull out dy dx. So 8xy to the 7th minus 5x to the 4 minus 2 equals 12y squared minus 28 x squared y to the 6 y dx. That's horrific. Now, I wanted to just say dy dx equals something. So I'm going to divide by this on both sides. So I'm going to write my final answer in red because this is just getting crazy. Dy dx is going to be 8x to the y to the 7th minus 5x to the 4th minus 2 all over 12y squared minus 28x squared y to the 6th. Okay, and that's the answer. It just gets a little bit hectic with all the writing. But that is what you want. Dy over dx equals something. Now, do I know if it'll get this complicated? Do I know if it'll be as complicated as you've seen before in my sessions? I don't really know, but I know for sure she'll have at least 1 or 2 problems of it because it is something that students struggle with. So get very, very familiar and very, very comfortable doing it. I know you guys can do it because you work really hard at it, but this is something that is good to practice on again. Okay, again, same here. Implicit differentiation with respect to x. Again, over here is your simple stuff. This right here is going to be another product rule. I think, honestly, as hard as it's going to get is probably what you saw in the quiz last time you were in class, but it doesn't hurt to be good at the harder stuff. So let's go ahead and move forward with this problem. If you hear paper flipping, it's me double checking my work. Double checking my work as we go forward. So, product rule. I'm going to do that first just because it's the hardest piece of the puzzle. Where is my stylus? There it is. Okay. Okay, I just set this up really, really quick. Derivative of x times y squared plus x times the derivative of y squared. You know the derivative of x is 1, so 1 times y squared plus x times 2y. And since you're deriving with respect to x, and this is a y, you need to make sure you have dy dx on there. And I'm just going to clean this up a little bit, so y squared plus 2xy dy dx. And that piece is done. You don't have to worry about it anymore until you're ready to bring it back to the rest of it. Okay. So, dx 4x minus d over dx 6y. The derivative of 4x is just going to be 4 minus the derivative of 6y is just going to be 6 times dy dx. Oops. Oh, never mind. I miscopied. It'd be 6y squared. It'll be 12y dy dx. And then I'm going to bring this piece back over. Equals y squared plus 2xy dy dx. Okay, so again, I want to do the least moving and shaking as possible. I'm actually just going to move y squared over to this side, and then move 12y dx over. And if you don't like doing this in one step like I'm doing it purely for the sake of time. If this is too much at one time, it's totally okay. Okay? This is more just so I can keep it moving, because I do not want to keep spending time doing arithmetic I feel like you guys already know. Okay, I can pull out dy dx since it's on both of them. 4 minus y squared equals 2xy plus 12y dy dx. Again, I'm going to divide by this on both sides, so I want dy dx just to say something. So final answer in red, just so it's a lot of handwriting and it's not that great. 4 minus y squared equals 2xy plus 12y. Okay, and this is a 4. I don't know why it keeps giving it like a top line. It's a 4. 4 minus y squared all over 2xy plus 12y should be your final answer. And this is the only acceptable answer when it says dy dx. Okay, now we're on to our, actually my least favorite section, related rates. Okay, I always suggest you draw a picture, note down your givens and your unknowns, and then go from there. So a thin sheet of ice is in the form of a circle, so already circle. Think about all of the formulas that you know about circles. If the ice is melting in such a way that the area of the sheet is decreasing at a rate of 0.5 meters per second, at what rate is the radius decreasing when the area of the sheet is 12 meters squared? So I'm going to draw my little picture. I know it's like an oval. Please don't bully me. We are decreasing. Okay. So dA over dt is that movement of decreasing. And then I was given a radius. Okay, cool. So area, okay, so givens, I was given the rate of decreasing, and remember that's a negative because I'm decreasing. Negative 0.5 is decreasing area, okay? I have the actual area, which is 12, and I'm looking for the rate of the radius decreasing. Okay? That's everything I know about this problem so far. I also know the area of a circle. And it should be pi r squared. Now, before I get too crazy, I need r. Now, what is r? That is going to be I need to find r. So if I want r by itself, I'm going to divide by pi. That gives me r squared equals a over pi. and then r squared square root. So r equals a over pi. So whenever I insert this into my equation, I'm going to put these numbers in. It should be 12 over pi square root, which will be 1.9554. So now I have radius. I need that for after I derive. But anyway, so I needed to make sure I had r. So now I have r. I'm looking for the rate of the radius changing. I have area, and I have dA dt. So now I need to go in and derive. So, and I always derive with respect to time. Never anything else in these problems, okay? In this scenario, I can take pi out and move it because it's a coefficient. So I'm going to do that. The derivative of a with respect to time is going to be dA dt, and then pi, and then r squared is, let me just, so I have dA or dt equals pi, and then r squared, that's going to be 2r times dr dt. Okay, now I can plug in some numbers now, or I can move things around so I have dr on one side and then everything else on the other. In this problem, I moved things around and then plugged and played. You can do what you want. It really has no effect on the answer. If I want to, I can plug the numbers in right now, which is going to be 0.5 equals pi times 2 times 1.9544. No, 554. Blah, blah, blah. Words will help. dr dt. And then divide all of that. So 5 times 2. It should be negative 0.4. No, sorry. 0.040717 meters per second. Nope. I don't box it like that. I can tell you for certain that she will have 2 questions at least of related rates. One will be a 2D shape and one will be a 3D shape. I also know for a fact you probably will not have to do anything where you relate R and H. So a cone question will probably be out just based on that. And that's that. Okay, so next question. A spherical balloon is inflated with gas at the rate of 600 cubic centimeters per minute. How fast is the radius of the balloon increasing? At the instant the radius is 70 centimeters. So again, I'm going to draw a nice little picture for y'all. Please don't judge my drawing skills. That one turned out better than the first one. Okay, that's my nice little sphere. This is my radius of my sphere. Okay. And it is getting bigger. So that means dA dt is again expanding outwards. I have an R, which is 70. So let me write down my givens. So I have dA dt, which is 600. R is 70. And I'm looking for dr dt. Excuse me, it's not dA, it's dV. dV over dt. Yeah, when you're inflating something, it's volume. Oopsies. When you're filling something up, it's volume. My bad, guys. Okay, so, and you also know the volume is 4 over 3 pi r cubed. Yes, cubed. So whenever I differentiate this, I'm going to take out that 4 and 4 over 3 and pi. But before I do that, let me just... Okay, everything is always, again, with respect to time, because it's happening over a period of time. So the derivative of v with respect to t is going to be dv over dt equals 4 over 3 pi. And then the derivative of r cubed with respect to t is going to be 3r squared dr dt. Again, start plugging and playing. 600 equals 4 over 3 pi times 3 times 7d times, not times squared, squared times dr dt. At this point, I usually move everything over. And at the end of all of that nasty number mess, I have 0.00974 cm per minute. And because it's increasing, it's going to be positive. For questions like these, I always say draw a picture. Label your givens. Write out any formulas you know. And then derive. And then plug values in. My big rule of thumb would be to go back and try a couple of these problems. I know for sure she'll have a 2D and a 3D shape on here. I don't think a cone will be one, just because you won't have to relate R and H, but it would be good to start trying to memorize some of these formulas right here, because you do not want to be caught slipping and not knowing a formula like that when you know how to do all of this work, okay? So let's keep on keeping on. I think probably a good one for you guys to be aware of would be the ladder. That's Pythagorean. But really, honestly, I think anything is fair game. I don't know what shape would be on the test. I just think that they always go for a ladder. I've never not seen a ladder question on the test. But again, don't just study the ladder question. I would study a bunch of questions. I would go over any classwork you guys did and redo them yourself. Any homework that you were struggling with but you think would be easy enough to be on the exam. And please, please, please do your review so that we can see what type of questions she's asking. Okay, and the final one, your position function. I would like you to draw your attention really quick. Okay, so velocity is always the first derivative. Acceleration is always your second derivative. I know she'll at least have one of these questions on here. I don't know how hard it's going to be, so I put one on here, but I don't think it's going to be much more complicated than this. I would also like to say anytime something is dropped from somewhere, dropped being the key word, your initial velocity is 0. Not that that really matters right now, but that is good to know. So whenever you come across a question, you know v initial is 0. In this instance, that's how that's working. Okay, so let's start on this question. Oh my goodness. Suppose the position function of a free-falling object on a certain planet is given by this equation. A silver coin is dropped from the top of a building that is 1380 feet tall. Find the velocity for the coin at 1 second, and then what is the acceleration of the coin after 11 seconds. So let's find first. So if I really, really wanted to, I could do a little bit of substituting first before I find the first derivative. Because SO is going to be this height right here. So if I wanted to find that first derivative, it's going to be negative 22t plus VO. And that's it. So in this scenario, since you know VO is going to be 0, it's going to be negative 22 times 1 plus 0. Because we just said it's being dropped. You don't have an initial velocity. If it's thrown, there will be an initial velocity. But again, they usually state that in the problem. So if you're given an initial velocity, so VO equals some number, then you'll plug it in here. But otherwise, you don't have anything. So that'll be negative 22 feet per second. And that's your velocity. Okay? Now coming over here to acceleration, you are taking the derivative of negative 22t plus VOT. So to take the derivative of this, it's just going to be negative 22, and that's it. This should just be V. Yeah, it would be, no, I did it. Negative 22. And because you don't have t anymore, it's just going to be feet per second squared. Now, obviously, if you get a harder question than this with more going on in this piece right here, then this will change. The acceleration will change, the velocity will change, there will be something that will be different. But really all you need to know is that velocity is first derivative and acceleration is second derivative, and you guys can do those really, really easy. I don't think it's going to be a hard question for this. I think it's just for her to test if you understand how position formula works and velocity versus acceleration. Okay, that is the end of my presentation. I hope that I answered everybody's questions. And if you guys have any questions, please email me before the exam. I am happy to answer, and I am available to talk really, really fast if you guys need any help. I think you guys are very, very prepared for this exam. I think you guys are going to do great. I would study inverse trig functions. I would study my exponentials and logarithms. And I would go over some of my related rate questions, just so then that way you guys have a little bit of an upper hand. I would also make sure that you finish up your exam reviews and practice exams, because those are really, really important. And those are essentially a one-to-one example of your tests. So that's it. That's all I have for you guys today. And I will see you guys on Monday.